Let's continue example 17.4 with part B. We have two functions provided here. We want to verify or determine really whether or not they are inverses. We don't know that they are. So let's start with the composition of f with g. And it doesn't matter which composition you start with. Just pick one and go with it. I like to start with f composed with g. This is going to be f of x plus 5 over 9. So I'll substitute that in. 5 times x plus 5 over 9 minus 9. Now, when we look at the order of operations here, plus 5 is first, divide by 9 is second, multiply by 3, or multiply by 5 is third, and then subtract 9 would be fourth. None of these are inverse operations. The plus 5 doesn't go with the minus 9. The divide by 9 doesn't go with the multiply 5, so there's no cancellation that occurs here. Now, this would lead me to believe that if there's no cancellation, then we're never going to get down to just x. And so at this point, you might feel comfortable saying these are not going to be inverses of each other. But I'm going to go ahead and take it a step further just to show what you might do with something like this, because this is something that we had back in section 5. It was just an exercise, hey, find the composition. We didn't really do anything with it other than just find the new equation and write the new function definition. But here, we're using it as a means to determine if we have inverses. So what I would do first is multiply 5 to the x plus 5 over 9, which means it just gets multiplied to that numerator. This is going to end up saying 5x plus 25 over 9 minus 9. And then I can divide 5x by 9, call it 5/9 x, divide the 25 by 9 minus 9. And we could, of course, combine these constants together and we would end up with something that's linear. But I think it's very apparent now that this is not going to be equal to x. It's just not going to happen. And so as soon as you realize that this is not going to be equal to x, you can then conclude, therefore, f and g are not inverses of each other. So it's important to note that it takes two special functions with the right operations in the right orders to be able to be inverses of each other. You can't just randomly select two functions and expect them to be inverses. The chances are very unlikely. So even though on these two functions we have 5 and 9 on both of them, they weren't the right operations and they weren't in the correct order to get the cancellation that we wanted to occur. So even with the right numbers, it may not necessarily work out. You've got to have it in a very special ordering there. So example 17.4b is not inverses of each other for f and g.